For the inverse cosine function, inverse cosine we can also write as arc cosine. For this, we're trying to get the number or the angle in the interval between 0 and pi, whose cosine is x. Now the reason we're going between 0 and pi is if we look at the graph of our cosine function, our cosine function looks like this. If we want this to be a one-to-one function, then we're going to have to cut off anything from here on or anything from here on. So we're only going to go between here and here for the cosine function, and that's 0 and that's pi. So our normal domain for cosine is negative infinity to infinity. We're going to restrict it to 0 to pi. And then for cosine, just like for sine, our range is between -1 and +1. To do the domain and range for our inverse function, we're just going to take these two and switch them. So the domain is going to be from -1 to 1. The range is going to be from 0 to pi. This makes this one a little bit different than sine, because this is going to be in the first and second quadrants. So these are all going to be positive values, and this is 0, and that's going to be either a first quadrant angle or a second quadrant angle. Let's find some values for inverse cosine. Remember, it's the same as arc cosine. So here, again, there's kind of two different ways to go about this. If you want to use the inverse of arc cosine, that would be cosine. So you could do cosine of y on each side of this. The cosine and the arc cosine cancel each other out, so you would just end up with cosine of y equals 1. Or the other way we thought about this is to take the inverse of this function, which is cosine, and then to switch the other two things. So you put the y into the cosine function, and the 1 would go to the other side of the equation. Either way, what we're looking for is the angle that has a cosine value of 1. Where that happens is at the angle 0. So this means y equals 0, and that's either in radians or in degrees. Let's do the same thing for this one. The inverse of this function would be cosine. So if we write down cosine, then we're just switching the y and this value. So this is going to be y inside of here. This value goes over to the other side. Now we're looking for an angle that has a cosine value of -√2/2. And we want to remember the range for inverse cosine. Where cosine is negative is either the second or the third quadrant. The range for inverse cosine is either the first quadrant or the second quadrant. So we want the second quadrant angle that has this value. This is one of the values for our special angles. It's the one for 45 degrees or pi/4. That would be the reference angle. In the second quadrant, that would be either 135 degrees or 3 pi/4. Now let's look at the graph for the inverse cosine function. Again, we've got some function values. If we have -1 for x, the angle that has that as a cosine is pi. And notice that all of these values go between pi and 0. And what happens as our x values increase from -1 to 0, our inverse cosine values actually go down from pi to pi/2. So this is decreasing from here to here, and then as x goes from 0 to 1, this decreases again from pi/2 down to 0. And if we look at the graph, we can see that happening. Our y values are starting up here at pi, and by the time we get down here, they're down to 0. So this is a decreasing function across its whole domain. Our domain for this is -1 to 1. Our range is 0 to pi. This graph is decreasing and continuous across the entire domain, so from here to here there are no gaps or jumps or vertical asymptotes. Our x-intercept is right here, so that's at 1. and our y-intercept is right here. That's halfway between 0 and pi, so that would be at pi over 2. And this graph isn't symmetric with respect to either the y-axis or the origin. One more function that we're going to look at is the inverse tangent function. So we can write it as inverse tangent with the -1, or we can write it as arctangent. For this one, we're going to just look between negative pi over 2 and pi over 2. If we look at the graph of our tangent function, remember this one we had vertical asymptotes at negative pi over 2 and pi over 2. So our domain, when we talked about the entire tangent function, we had to leave out all the odd multiples of pi over 2. But what we got there was a repeat every pi. We want to take out all those repeats because that would make this not be a one-to-one function. So we're just going to look at the one panel of this which goes between negative pi over 2 and pi over 2. So we're going to restrict our domain. And since these are vertical asymptotes, we can't actually include those numbers in the domain, so we're going to use parentheses here instead of square brackets. For the range of tangent, if we look at our y values, we're going all the way from negative infinity to positive infinity. If we do the domain and range of our inverse tangent, we're just going to switch these two. So our domain is going to be negative infinity to infinity, and our range is going to be from negative pi over 2 to pi over 2. If we look at some of our function values, and these are just a few of them, obviously since our domain goes from negative infinity to infinity, we could go out a lot further with the x's on either end. What happens with this is that as x increases from negative infinity up to 0, what happens with our y values, our angles, is that they go from negative pi over 2 up to 0. So the furthest down they can go is negative pi over 2, and we can't even include that negative pi over 2. And then as our x's go from 0 to 1, our y values, our angles are going to increase from 0 up to pi over 2. And again, we can't actually include the pi over 2. What that does for the graph is it gives us horizontal asymptotes. So we have a horizontal asymptote at negative pi over 2. That means on this end, this is going to keep getting closer to that line y equals negative pi over 2, but it's never actually going to hit it. And the same thing up here, this is going to get closer to this horizontal line, but it's never actually going to intersect that line. The facts about inverse tangent, our domain is negative infinity to infinity. Our range is negative pi over 2 to pi over 2. The graph is increasing and continuous over the whole domain. So as we go from negative infinity to infinity, there are no gaps or jumps or vertical asymptotes in any of this. The x-intercept and the y-intercept are both at 0 because this goes through the origin. This graph is symmetric to the origin, so that makes it an odd function. That means if we have a negative in here with our x, we can just pull it to the outside. And then the last thing is our two horizontal asymptotes. So the lines y equals negative pi over 2 and y equals positive pi over 2 are horizontal asymptotes for this function. Now we do have inverse functions for the other three trig functions. These ones we don't use a whole lot, so we're not going to go into a whole lot of details for them. The important things to notice are the domains and the ranges. Just looking at the graph for inverse cotangent, notice the range here is going between 0 and pi. Now for this one, the range is going from 0 to pi, but we've got this horizontal asymptote in the middle, which actually splits this into two halves. So this part goes from 0 up to pi over 2, and then this part goes from pi over 2 up to pi. So that one, the range is kind of strange. And the same thing for this one. This is actually split into two pieces. So this part of it goes from negative pi over 2 up to 0, and then the part up here goes from 0 up to positive pi over 2. Now to find function values, if we've got inverse tangent or arctangent, this is one that we have a key for on our calculator. But we can do this one the same way that we did with sine and cosine. So we could either do the tangent on both sides of this, and then the tangent and the arctangent would cancel each other out. Now we're looking for an angle that has a tangent value of 1. That would be at pi over 4. Or if we were doing this in degrees, it would be 45 degrees. For this one, we can do the same thing. So we can use the inverse of this function, which would just be secant. The theta is going to come over here to the inside of the secant, and then the 2 goes over to the other side. Let's use our reciprocal identity to rewrite this. Secant is the same as 1 over cosine. If we did the reciprocal on this side, we'd get 1/2. The reciprocal of secant is cosine. So we'd have 1/2 equals cosine of theta. We want an angle that has a cosine value of 1/2. That would be the angle pi over 3, or in degrees it would be 60 degrees.